Hey guys, this is video number 2. So if you haven't watched video number 1, you might want to go back and watch that one real quick. So video number 2 is about the limits approaching infinity for non-rational functions. So one of the two functions is not a polynomial function. So usually when this is the case, you're going to use direct substitution and try to analyze. Let's look at an example of that. Okay, so you'll notice that this is what we call an exponential function. An exponential function is when the exponent is a variable and we have a number that's being raised to it. Okay, so we can't really do the degree rule here because those aren't the degrees. So let's go through and get what we would if we would do substitution. So it says substitute positive infinity. So that's what I'm going to do. I'm going to go in and do a little positive infinity. So I get 6 to the infinity and 5 to the negative infinity. Now, do you remember what we've said about in the past about negative exponents? A negative exponent just means do the reciprocal, and then you can make the exponent positive. So, or put a 1 over it, and you could make the exponent positive. So I went from just plugging in infinity, noticing that there was a negative exponent, so putting a 1 over it and making the exponent positive. And then remember, keep, change, flip. Does that ring any bells? So keep, change, flip means I'm going to do 6 to the infinity times 5 to the infinity over 1. So what does that mean? I have a gigantic number and I'm multiplying by another gigantic number. So that is going to result in yet another gigantic number. In other words, the limit as x approaches infinity does not exist, or the limit as x approaches infinity approaches positive infinity. And here's the graph of that function. And you can see that on the right-hand side, this graph is going to infinity and beyond. So we can see that the limit does not exist. It does not approach an intended height. It's just going to the unisphere or something, or the atmosphere. I don't know why I say unisphere. All right, let's try another one. This is asking me the limit as x approaches negative infinity. So it's basically asking me where's the left-hand side of the graph ending up? What is its end behavior? Let's look at the graph real quick. Looks like the left sides of the graph's end behavior is 0. So let's see if we get 0 when we try direct substitution. So I'm going to plug in my number into these two numbers. Okay, and what do you notice about this minus? Remember probably your teacher before you said make that a plus right there. And then what did we just say about this negative exponent, how we can make that a reciprocal? And the way you do a reciprocal is you put a 1, you put the term in the denominator, and then the exponent becomes positive. So we have 5 to the infinity. Now, I just want to remind you, you have, like, not remind you, but kind of tell you, you have one piece of pizza and a gajillion people are splitting that pizza. How many bites are you getting? How many, like, food are you getting? What kind of sustenance are you getting? Like nothing. So 1 over a huge amount is basically just approaching 0. And so 0 divided by 5 over the 5 to the infinity, which is another gigantic number. Well, 0 over anything that's not 0. So 0 over 1, 0 over 10, 0 over anything results in 0. So with direct substitution, using my little algebra skills here and using the logic that 1 over 6 to the infinity is basically just 0, we get our answer 0. Okay, so let's try another one. Okay, here's another one that's like direct substitution. Here's the graph of this particular function, so you can see what the end behaviors are. So this one is asking me the limit as x approaches infinity. Your brain says, oh, it's asking me about infinity. It's asking me about the end behavior. So what is it doing on the right-hand side of the graph? I should get 0 for the answer to this problem. Let's see what we get. I'm going to plug in positive infinity. I get 3 to the negative infinity over e to the infinity. What do I do with that negative exponent, ladies and gentlemen? Do you remember? You put a 1, then you make it a positive exponent all over e to the infinity. What did we just talk about? 1 over a gigantic number is going to be 0 all over something that's not 0. So that is going to be 0 as well. So that checked out. We got that the limit as x approaches infinity of the function is 0. Let's try this guy. This says, what's the left side end behavior? Now, ladies and gentlemen, if it's saying the left side, let's look at the left side of the graph. Looks like it's going to infinity and beyond. So let's see if that's what we get. I'm going to plug in negative infinity into this. Oh, what did your past teachers tell you about negative? They probably told you, they probably did this on your paper, make a positive. So now we have the limit as x approaches negative infinity of 3 to the positive infinity over 1 over e to the positive infinity, because we have this negative reciprocal or negative exponent. So we do the reciprocal, and then we look at that and we go, hey, keep change flip, everybody. And we get 3 to the infinity times e to the infinity over 1, and that looks like a pretty gigantic number. 3 to the huge power times e to the huge power, we get a very, very big number. So there's our answer. Now, again, if this is a free response question and you wrote does not exist for this particular problem, you are correct. There's nothing wrong about that. But these problems tend to be multiple choice, where does not exist is not an option. You have to get whether it's going to be positive infinity or negative infinity. Okay, so this was horizontal asymptotes that are not rational functions that require some direct substitution and algebra manipulation. Let's stop this recording, and then I'm going to go into recording number 3. Hope you made it this far.